As first speaker in my talk, I will be speaking about circuit lower bounds. I will be speaking about circuit lower bounds for predicates which are defined by probabilistic proofs. These proofs are called Merlin-Arthur proofs. Merlin generate proof Y, and Arthur verify this proof. Arthur in their work may use random bits. So we need some promise. Note that Merlin-Arthur is a generalization of class NP, so NP subset of class Merlin-Arthur. Also, Merlin-Arthur is subset of second level of polynomial hierarchy. In my work, I proved lower bounds for Boolean circuits. Boolean circuit is labeled DAG, and in this slide was shown example of circuit. This circuit evaluates sum of x, y, and z, and result is sum and carry. Okay, the set of languages which are acceptable by circuits with n to k gates are denoted as size n to k. Note that polynomial side family of circuits is a generalization of polynomial time Turing machine. So if NP is equal to P, then NP is subset of union of K's, union by K of size n to K. So proved superpolynomial lower bounds is very hard. Canaan in 1982 proved that for any polynomial circuit complexity of second level of polynomial hierarchy is more than this polynomial. But for NP, this question is still open. The next step in this research is prove lower bounds for Merlin-Arthur class. But the best results which are known now is Santanam's theorem. Santanam is in 2006 proved that Merlin-Arthur with one non-uniform bit have circuit complexity more than any polynomial. What does it mean, Merlin-Arthur with one non-uniform bit? It means that Arthur in their work may use one bit of witness, which depends only on length of x. And this witness may be non-computable. In my work, I want to eliminate this bit of witness. And I remove class Merlin-Arthur with one bit of witness and choose heuristic version of class Merlin-Arthur. What does it mean, heuristic class? It means that we allow to our machine doesn't work correctly or make errors on small parts of inputs. For example, for class Merlin-Arthur, we introduced family of sets S with big sets, such that on inputs from S, our protocol works correctly and following the promise. We can introduce this definition for circuits, and heuristic version of class size n to k is the following. This definition is similar, but there are parameter j or g, which is the size of error. In my work, I proved that in a class of heuristic Merlin-Arthur, there are languages that its complexity, heuristic complexity, is more than n to k. A variable exists for all k. So for all exist A such that for all k this statement is true. That's all. Thank you for your attention.
Yeah, but what is this set? What is
The set is complicated, but it's based on p-space complete language, which allows reductions worst case to average case. So firstly we prove that that if this language doesn't acceptable by worst case circuits, then it doesn't acceptable by average case circuits, because if it's acceptable, we can make a reduction to worst case from average case.
But how you get the class in heuristic MA from p-space?
We make padding with we pad our language such that it's acceptable by circuits of polynomial size of inputs, but more than n to k.
But still you start with p-space complete language?
Yes.
And after padding, it's by some miracle becomes in MA.
Yeah, it's very big padding. It's more than polynomial padding. If we take exponential language and pad exponential bits, it's language from
yeah, but
P,
it's strange,
for example.
By padding, you just can decrease the complexity up from p-space to just to MA, but not, for example, not to P. So it's
we use that our Merlin-Arthur protocol may works polynomial time, not n to k, but our circuits must works n to k times.
Okay, so it's Merlin, so it's not a surprise that miracle can happen.
It results like when we
how you construct MA protocol from p-space?
Merlin sends to Arthur circuits which decide language from this circuit which decides this protocol, and Arthur check that this is a correct circuit, and after that use it. But I may write.
So you simulate a prover in interactive protocol by circuit? Or?
Yeah, yes, we simulate a circuit which solve, but this size of the circuit is n to k plus 1, for example. Yes?
Have you tried to prove some lower bounds, not to Merlin-Arthur protocol, but for Arthur-Merlin?
Lower bounds for Arthur-Merlin, Merlin-Arthur is equal. If Merlin-Arthur if complexity of Merlin-Arthur is more than any polynomial, then complexity of Merlin-Arthur is 2.
Yeah, but you have proven for MA protocols. I'm asking you.
MA is subset of AM. So.
Yeah, so
in the worst case, without a heuristic in the here, yeah? You mean?
no, MA is a subset of AM, right?
Yeah.
So are there any lower bounds for AM?
Yes, this lower bounds is still true for MA, for AM. AM is more bigger class. So any language from heuristic MA is a language of heuristic AM. Maybe I don't understand the question.
Any other questions? So if not, let's thank Sasha and all the speakers.